Okay, section 6.3 is a continuation of trig equations. This is part 2. And what we're going to see in this section is that we're going to be working with angles that are more complicated than x. So that what we're plugging into our trig functions isn't just x, but is some multiple of x. Like in this case, we've got 2x. Directions here are the same as they've been in the past. Find all the solutions between 0 and 2 pi, and then find all solutions. Okay, now when you see this, you might think, oh, I got to use the double angle formula. We actually don't. Okay, with a lot of these problems, even if they involve 2x or 3x or 4x, we're not going to be needing to use trig identities to solve them. There may be somewhere we do, but here's what tells me that I don't need to use the double angle formula in this one. Okay, 2x is the only angle in this problem. There's no other thing that I'm plugging into a trig function. So there's one angle, and cosine is the only trig function. One angle, one trig function. I don't need to use an identity, because the identities, the double angle formula, would write things in terms of a different angle x. I would have to change the angle. There's no need to change the angle here. I can just try and figure out what this angle is. Now, when you are asked to solve an equation and it says find all solutions, either all solutions between 0 and 2 pi or all solutions, that's finding x. Okay? So when you're solving an equation, you're finding the value or values of the variable that make it true. So we're ultimately looking for x. But what I'm going to do is I'm going to find 2x first. I'm going to find what angles I can plug in for 2x that would make this equation true. And then once I know 2x, finding x is easy because all I have to do is cut it in half. Okay. So anytime I have a situation like this, what I'm going to do is I'm going to find all the values that 2x could be in the interval from 0 to 2 pi in one period of that trig function. Okay. Then I'm going to find all possible values of 2x. Okay. So I'm going to go through the same steps that we've been going through in solving for an angle. It's just once I've done these two steps, I'm not done because I don't know what x is. I know what 2x is. But once I have that, I'm going to be able to find all values of x. Okay. And once I have that, I'm going to get x in the interval from 0 to 2 pi. Okay. So when we're solving for the angle we can plug into an equation, we usually start by finding all of the angles in one revolution around the unit circle. Then we pass to all the angles. Now, when I'm going from 2x to x, if I know a formula for all 2x, it's going to be easy to get all x, and then I'll get the specific one. So I'm actually going to end up answering these questions in the reverse order, just because of the strategy that I use. Okay, so let's see how this works. Okay. Here, I don't have any cosine squared, so this is not quadratic. This is what we call linear in cosine, because it's just cosine to the first power. So when I have that, I know that what I want to do is isolate the trig function. So I've got 2 cosine of 2x equals negative root 3. Then I can divide both sides by 2. So cosine of 2x is negative root 3 over 2. So I want to figure out what angles 2x could be. So if I think in terms of quadrants, I know there's no solution in quadrant 1 because cosine would be positive there. There will be a solution in quadrant 2. I'm just going to label so that I don't forget and think that's my final answer, that that's going to be 2x. There will also be a solution in quadrant 3. So there's a value of 2x in quadrant 3. Okay. And both of these will have the same reference angle, alpha. Now, what I know about alpha is that cosine of alpha is the absolute value of negative root 3 over 2. So that would be root 3 over 2. So alpha's an acute angle whose cosine is root 3 over 2. That just makes me want to draw a 30, 60, 90 triangle. 1, 2, root 3. Looks like we're looking for 30 degrees, which in radians would be pi over 6. Okay. So in this picture, 2x is pi minus pi over 6. So 2x would be 6 pi over 6 minus pi over 6, which is 5 pi over 6. So that's my first answer for what 2x could be. Okay. All right. Then in this picture, we're getting that 2x is pi plus pi over 6. So that would be 6 pi over 6 plus pi over 6, which would be 7 pi over 6. Okay. Now you'll notice if 2x is 5 pi over 6, I could at this point have solved for x. I'm not doing that for a very specific reason that I'm about to show you. Okay. So now all values of 2x, that would be 5 pi over 6 plus 2 pi n, or 7 pi over 6 plus 2 pi n, where n is an integer. Okay. So those are all of the values that we're going to get for what 2x could be. Now I'm ready to solve for x. Okay. So if 2x is 5 pi over 6 plus 2 pi n, if I want to solve for x, I just need to divide by 2. But I need to be careful because I'm not just dividing that by 2, I'm dividing the whole thing by 2, which means I'm dividing each piece by 2. Now here, I'm going to just use the fact that dividing by 2 is multiplying by 1/2. I think a moment ago I might have said 5 pi over 3. It would be 5 pi over 12 when I do that. Okay, if I said that. Sorry, I don't remember for sure if I did. Okay, but x would now be 5 pi over 12 plus pi times n. Okay. Notice what I'm adding to it is half of 2 pi because that got cut in half as well. Okay. So that's why I waited until I had added the 2 pi n to cut things in half. Because it's tempting at this point to solve for x and say we get 5 pi over 12, which is what we would get, okay, and then add 2 pi n to that. But we're actually only adding pi n, and we'll take a look at this graphically in a moment to sort of see why. So I like to do things in this order. Now, if you had preferred to divide by 2 here, and you remember that you're not adding 2 pi n, but that you've got to cut that in half as well so that you're adding pi n, that's okay. You don't have to do things in exactly this order. But this is a nice systematic way that I'm going to stick to, and by finding all of the 2x before I find all of the x, that just reminds me that the whole thing, in this case, gets divided by 2. Okay. All right, so my other option was that 2x could be 7 pi over 6 plus 2 pi n. If I divide by 2, again, that's the same as multiplying by 1/2. So x is going to be 7 pi over 12 plus pi n. Okay, so all the values for x we now have. So I've got 5 pi over 12 plus pi n, and I've got 7 pi over 12 plus pi n. Okay. So now I need to find all x values that are between 0 and 2 pi. Okay. So they're going to follow one of these two formulas, and what I'm going to do is I'm just going to record what n is and then what x is. If n is 0 here, I would get 5 pi over 12. That's definitely between 0 and 2 pi, so I want to keep that. If n is 1, 5 pi over 12 plus pi times 1 would be plus pi. That would be 5 pi over 12 plus 12 pi over 12, that would be 17 pi over 12. That is still between 0 and 2 pi, because all I added to this was pi, so it didn't take me over 2 pi. We're used to, we have our answers and we add 2 pi n. So if you add 2 pi to something, it's going to take you outside. If you started between 0 and 2 pi, when you add 2 pi, it's going to take you out of that window. But here, I could add pi and I'm still in the interval from 0 to 2 pi. Now, if I were to add pi again, that would be another 12 pi over 12. That's going to take me to 29 pi over 12. That's bigger than 2 pi, because 2 pi would be 24 pi over 12. So these are the two solutions that I get from here. Okay. Now, using this formula, I can do the same thing. If n is 0, I'm just going to get 7 pi over 12. If n is 1, I'm getting 7 pi over 12 plus pi, which again is 12 pi over 12. That's going to be 19 pi over 12. That is still smaller than 24 pi over 12. So I actually end up with 4 solutions between 0 and 2 pi. So here's 5 pi over 12, 17 pi over 12, oops, that's over 12, 7 pi over 12, and 19 pi over 12. That would be my answer for all the values of x between 0 and 2 pi. Now, graphically, what's going on here is we were working with cosine of 2x. If I were to graph cosine of 2x, it basically has a period of pi, because the period, remember, is 2 pi divided by the number that we're multiplying by x, so that would be pi. So this goes through one complete cycle between 0 and pi, which means it goes through a second cycle between pi and 2 pi. If we were looking for all of the places where cosine was negative root 3 over 2, we're used to there being 2 solutions in one period. But now we get a second period in the interval from 0 to 2 pi, so that's another 2 solutions. So because cosine of 2x, you can think of it as we're going twice as fast, so we cover the distance in half the time, that's going to double the number of solutions that I have. So there were only 2 solutions for what 2x are, but there are twice as many solutions for what x could be, because we're essentially repeating those values, but still within the interval from 0 to 2 pi.